Good morning and happy Wednesday. So today it's really important that you go to Google Classroom and read what it says in there to make sure you get everything accomplished. Remember that I am not probably going to give you a ton of time to work on your weekly work tomorrow, and it is due tomorrow, so make sure that you're using your time today to make that happen. If you remember yesterday, we talked about standard form, and then from there we started talking about intercepts at the end of class. So we talked about x-intercept and we talked about y-intercept. So today we're going to talk about how you can find those things algebraically, and then how we can utilize standard form to graph, because if there was a reason why I would use standard form, it would be because you can easily find intercepts and then graph from there. Just as a reminder, remember we talked yesterday, if you're looking at a table, we said that if your x value is 0, anytime, that's always going to end up being your y-intercept, because we talked about how our y-intercept is always going to be a point that is 0 and then some number. And then we said in this case, this table, 12 would be my x-intercept, because your x-intercept is always going to be a number and then 0 for y. So now we're going to talk about algebraically. So we're going to go back to this first example. So at the top, it tells us that linear graphs will have at most one x and one y-intercept. That means that never will you have two x-intercepts, never will you have two y-intercepts if it's linear. If it's a straight line, it's not going to happen. And the only exception to that rule would be if you have x equals 0 or y equals 0. That would be awkward, because x equals 0 would be a vertical line, y equals 0 would be a horizontal line. And then that in that case, either of those cases, everything would be an x and y intercept, because it would be on the axes. But anyways, in example 1 and example 2, we're going to talk about how can we figure out our intercepts just algebraically. So if I look at number 1, here's what you need to remember. If I'm looking for my x-intercept, I am going to replace wherever I see the y value with a 0. Well, if you think about it, and you go back to the example we just talked about, if we look at x-intercept, which we talked about right here, our y value is 0. So anytime I'm looking for an x-intercept, I can replace wherever I have a y with 0, and I'm going to end up with my x-intercept. So let's look at number 1. I am going to simply replace anywhere I see y with the number 0, which is actually going to make life pretty easy because we like 0. Anything times 0 is 0. So this is just going to become 0. So it's just going to leave me with 9x net x equals 72. Divide by 9, and my x value is going to be 8. Remember, I'm looking for my x-intercept, and if I look at the point that I just created, the x value is 8. The y value that I plugged in was 0. That means my x-intercept is the point 80. Mind-blowing, I know. And yes, it's always going to be pretty much that easy. So let's do the same thing, repeat the process, but let's do it for our y-intercept. Well, if you're looking for your y-intercept, same process, except for if you go back and look at our table, our x was 0. So anywhere you see an x, you're going to replace it with 0, and that'll give you your y-intercept. So using the same standard form, and I'm just going to repeat process. So I'm going to say 9 instead of x, I'm going to put 0, plus 16y equals 72. This is going to give me 0, so I'm going to say 16y equals 7, stressing me out because it's not what I wanted. But, oh, it's 72. That's why I was like, that's stressing me out. It's not a very big number. It's okay if you end up with a decimal, because sometimes lines cross the x and y axis at decimals. We are going to actually turn it into a decimal because we're essentially going to be plotting points. And when you want to plot points, you don't want to plot points as weird fractions. So we are going to turn this into a decimal. So we're going to say that y equals 4.5. And then if I wanted to write this as my point, remember my x was 0 and my y was 4.5. This is my y-intercept. Again, it's really easy, but it's also one of those situations where it's really easy to get things confused, just because you're like, do I plug in for X? Do I plug in for Y? What's going on? So it's really, really, really important, and I stressed this yesterday, that you remember y-intercept X is 0, x-intercept your Y is 0. Let's move on to example number 2. So in example number 2, first thing we're going to do, we're going to find our x-intercepts. So if I'm looking to find my x-intercepts, I'm going to replace 0 with y. So that's going to be 8 plus, in this case, it's just y, so I'm going to put a 0 there, equals 4x. When I simplify that, that's going to give me x equals 4x. When I divide by 4, my x is going to equal 2. When I write my x-intercept, my point is going to be 2. And then remember, my y was 0, so 2, 0. That is my x-intercept. What's going to happen is a lot of you are going to start wanting to not show me work because you can do the work in your head. I need to see something. If you jump in right here at this point and just show me that 8 equals 4x, that's fine. But what you can't do is just say x equals 2 and show me absolutely no work. You have to show me where you're plugging in your zeros. And then for finding your y-intercept, I'm going to repeat the process, but this time I'm replacing x with 0. So that's going to look like this. I'm going to have 8 plus y equals 4 times 0. That's going to leave me with 8 plus y equals 0. I'm going to go ahead and move 8 to the other side so that my y stays positive. So I'm going to have y equals negative 8. When I write my point, I'm going to have 0, negative 8, and that's my y-intercept. And that was my x-intercept. I'm aware that we didn't start in standard form in number 2. It's not necessarily a requirement to start in standard form if you're trying to find your intercepts. So it'll work either way. So remember, x, you're replacing y with 0, y, you're replacing x with 0. We're now going to go down to the bottom of your notes. If I can figure out how to make this happen, yay. We're going to go to the bottom of your notes, and we're going to do graphing with intercepts. So if I were to say, okay, I want you to graph an equation like this, hopefully you're saying to yourself, gosh, Self, that's in standard form. It is. And then, yes, you could rearrange it and write it in slope-intercept form, but I'm going to show you an alternate method of how you could graph it without doing that. So I'm listing my steps to the left, and then I'm going to work it out for you. So step number 1 says you're going to find the x-intercept. Remember, you're going to replace y with 0 and solve. So I'm going to split my workspace up, and I'm going to solve for my x-intercept. So to do that, I'm going to say 4x. Instead of y, I'm going to put a 0 here, equals 4. This doesn't matter anymore, so I'm going to say 4x equals 4. I'm going to divide by 4. Divide by 4, and my x is 1. Remember, if I wrote that as a point, my point would be 1, 0, because the y value that I plugged in was a 0. That's how I got 0 here. I just gave you your x-intercept. So from here, I can go ahead and I can graph that. So if it's my x-intercept, that means it should happen on the x-axis. So the point 1, 0, oh, what do you know, is located on my x-axis. To technically graph a line, I like 3 dots, but technically you only need 2. And in this case, when we're graphing using standard form and intercepts, you'll just have 2. So I'm going to repeat my process, and I'm going to find the y-intercept, and I'm going to do that by replacing x with 0. So repeat process, but this time it's going to look like this. I'm going to say 4 times 0 minus y equals 4. A lot of you are going to skip this step where you write it down. I'm at peace with that, but you do have to show me some kind of work. I'm not done at this point because I have a negative y, so I have to divide by negative 1 to get y by itself. Y is going to equal negative 4. So my y-intercept is going to be 0, negative 4. So now I can go to my graph, and the point 0, negative 4 should be located on the y-axis. And what do you know? It is. So now that I have 2 points that are on my line, I can connect my dots. And we want to try and make them as straight as you physically possibly can. And I'm probably going to be a bad example of that. Connect your dots. Make sure you draw your arrows because this line would keep going. It's continuous. That's all you have to do. All right, pause your video. Do the last example without me. Then unpause and see what you can come up with. All right, hopefully you've unpaused. Hopefully when you were looking for your x-intercept, you replaced y with 0, and that gave you 6x equals 28. I don't know why I put a 28 there. That's a 24. 24 divided by 6. And your x value should have been 4, so that's the 0.40. When you found your y, you should have repeated the same process, but you're going to put in a 0 wherever the x is, and that's going to leave you with 8y equals 24, and that's going to give you 3. 0, 3. Now I'm going to just plot my two intercepts. My x-intercept is going to be on my x-axis. My y-intercept is going to be on my y-axis. And I'm going to connect my dots. And I'm done. Again, this is just another way to graph a linear equation. Other than the method we've used, we're starting in standard form, and then we're utilizing our intercepts.